which is, so you're correct? You're correct? 1/3 of 30?
Right. Well, 10.
Yeah. Okay. And how about the circuit on the left? Well, to figure out the circuit on the left, we probably, or one way we could do it is first combine those two resistors in parallel. And if I combine a 6 and a 3 in parallel, that's going to give me, what? 2? Yep. 6 times 3 over 6 plus 3, which is 2. So I have a 2 ohm resistor and a 5 amp current source. So how much voltage would be dropped across that combined 2 ohm resistor? 10 volts. So if I combine those two into one resistor with 5 amps of current flowing through it, I'd have 10 volts. So the voltage drop from A to B would be 10 volts. Notice it's the same. So I haven't, again, proved it, but I'm claiming there's nothing you can do to tell the difference between these two circuits. They will behave the same. Now the good news for us is that if they behave the same, that means when I have a circuit, I can replace one with the other. If I have this in my picture, but it would be more convenient to have that, I can replace this with that, if it's more convenient for me. So I can, when analyzing a complex circuit, I can start to replace things with, including replacing current sources with voltage sources and vice versa. As long as I'm careful to make sure I've replaced that with that, I can replace things and make my circuit easier to analyze. Let me give an example. Okay, so we got a 5 ohm, a 5 ohm, a 3 ohm, an 8 volt, and a 5 volt supply. And suppose I want to figure out the voltage drop there. Call that V. I'm going to solve this circuit, not, oh, one question.
Is that supposed to be a resistor or just a thing in the bottom below the 8 volt?
Oh, no, sorry, that was just a, sometimes I'll draw a round dot.
Oh, that's reference.
Connection.
That's reference.
So I've connected the 3 ohm resistor.
Got it.
Sorry about that. I realize once I get to 11 o'clock and I'm drawing a circuit on top of previously erased stuff, it gets harder to see. So I want to find the voltage here, V. You could have solved this using nodal analysis, loop analysis, and frankly, especially when you're loop analysis or nodal analysis, at this point, since you're kind of new to this technique, and even for this circuit right here, I'm not going to claim that you're going to get a big gain in speed by doing it this way. This is a demonstration circuit. It's going to take me a couple steps, and probably since you're comfortable with loop or nodal analysis, you could do it loop and nodal in a faster amount of time than I can show you how to do it this way. Okay? I'll do this problem by what's called source transformations, switching back and forth as needed between Norton equivalents and Thevenin equivalents, and then I'll have you try one right after this. And probably after that, there will be time for Sean. Okay. To handle this circuit, I'd like to try to kind of combine all of this stuff together. I look at it right now, I can't combine it. I can't just combine those two in series. They're not in series. I can't combine those two voltages. They're not stacked on top of each other. There's nothing I can do. I'm doomed. I should just panic and go home or something like that. So with source transformations, what I can do is turn this voltage and resistor source into a current in parallel with the resistor source. So earlier I had an example where I probably shouldn't have fully erased it. I had that circuit, and that was equivalent to that circuit. Earlier that was 5 amps and 6 ohms, and that was 30 volts and 6 ohms. I'm going to convert this circuit, which matches this, into the Norton equivalent. I'm going to do that for this section. Actually, I've drawn a bad picture up here. So if you'll let me, I'm going to change my picture just a little bit. I meant to put my other resistor right there. And I'll throw another 5 on there. So let me just add one more resistor. So I'll put a 5 ohm and another 5 ohm. So I'm adding one extra resistor to my picture right there. So I know you've already all drawn your pictures, but this one illustrates the point better than the one I accidentally left off that extra resistor. Let me take this circuit, the 5 volts and 5 ohms, and try to replace it with a Norton equivalent. So I'm going to take just this section of it between point A and B, this part of the circuit here on the left, and I'd like to replace it with a Norton equivalent. So 5 volt and 5 ohms, I want to replace that. So what size resistor should I put here? So switching it over, I've got, we know that voltage is 5 volts and that's 5 ohms. What size resistor should I put here?
5.
5. Correct. That will actually always be the case. That wasn't a coincidence for the first problem we did. The resistor value for the Norton and the Thevenin will be the same. Now we figured it out the first time, but we can reuse that here. What size should that current source be?
1.
1, excellent. Because 1 amp through 5 ohms gives me the 5 volts I need. So I'm going to replace this with a 1 amp current source and a 5 ohm resistor. So I'm going to erase that and replace it with 1 amp and 5 ohms. I'll do the same thing with this 5 ohm and 8 volt source. I'll replace it between there and there. Note that this is an 8 volt in series with the 5 ohms. Okay, so I can replace that between this point and that point with a Norton equivalent. So I'd like to replace an 8 volt in a 5 ohm with some size resistor and some size current. What size resistor is it going to have? What size current is it going to have? 8 fifths. Excellent. Okay, so I'm going to replace that with that. That's 5 ohms, and this is 8 fifths amps. Edgardo.
So when you do a Norton, when you change it from Debian to Norton, right?
Yeah.
For Norton, they always have to be parallel from the current source?
Yes, yes. The Norton, there'll always be a current source in parallel with resistor,
Okay.
and for the Thevenin, it'll always be a voltage source in series. We're claiming those two configurations are equivalent if we pick the right sizes.
Would it be the same if you wrote it, if you had the 8 fifths amp and the 5 ohms going to both sides of the diagram instead of in a separate box?
Yes, yes. In fact, I'm about to do that. But I didn't want to, what I did was I tried to replace it from here to here in a way that you could see that it was clearly a replacement. So I drew it this way first, so you can see I just replaced that with that and tucked it in there. What I'm going to do next, which is actually, although I'm not doing anything other than redrawing the picture, it's a step that I think sometimes is hard to see. If I call this right here node X, I think you can all agree that that's also node X right there, right? And I can lengthen or shorten that wire on the picture without causing any trouble or changing the circuit at all. maybe what's a little bit less obvious to see right away is that point right there is also node X. In fact, that point right there is also node X. Everything along here, that's all the same node. So there's really no reason for me to draw this coming down and then splitting into two pieces. This is perfectly the same thing as drawing that line all the way up there and that line up there, as Isaac was suggesting. It's the same thing. It may be obvious to some of you. Typically that redrawing of the circuit, though, is what can trip people up, I think, as much as anything else in this problem. So I've replaced it, and now I've redrawn the circuit like that on the top, and I'm going to redraw it the same way on the bottom. Now I can see that that's in parallel with that, and that's in parallel with that. These two resistors are in parallel because their two tops are touching and the two bottoms are touching, and as such, I can combine the 5 in parallel with the 5. The 5 ohm in parallel with the 5 ohm gives me how much resistance?
2.5.
2.5. So I can replace these two 5 ohm resistors, which are now in parallel with each other. They weren't before. Now they are. That's in parallel with that. The 5 in parallel with the 5 can be replaced with one 2.5 ohm resistor. How about a 1 amp current source in parallel with an 8/5 amp current source? Can I combine, can I replace these two with one current source? And if so, what would the current be right there at that arrow?
1 plus 8/5.
2.6.
Fred, what do you think?
Oh, 1 plus 8/5.
Yeah, good, yeah. So 13/5, or 2.6. Okay, so these two current sources in parallel will produce can be replaced with one current source.
If they're,
Has an
if
amount
they,
of
I'm sorry,
2.6 amps.
if
Yeah.
the arrows were going different directions, would that have changed it?
Yes, then you'd have to subtract the two.
Okay.
So if I had 1 amp going up and 2 amps going down, they'd combine to be 1 amp down.
Okay.